Hello everyone. Today I will be discussing some problems related to journal bearings and axial friction. So I will not go through the derivation part of these formulas over here. M equal to, you can see, capital R into small r sine phi. So I will not go through the derivation part over here. So I will just jump into the maths directly. So here is our first problem over here. As you can see, uh, let's see what is said over here. A pulley of diameter 4 inch can rotate about a fixed shaft of diameter 2 inch. The coefficient of static friction between the pulley and shaft is 0.20. Determine, the number A of the question is, the smallest vertical force P required to start raising a 500-pound load, and B, the smallest vertical force P required to hold the load, the smallest horizontal force P required to start raising the same load. So the solution part is over here. This is our number A part. So as you can see, the free body diagram or the system will look like this. The 500-pound load is right here, as you can see, and the force that we are applying over here is P, denoted by P. So the system uh, will look like this. So for part A, vertical force P required to start raising the load. So when you are, raising the load, like you are trying to raise this load in upward direction. So when you are trying to raise the load by applying force P, the reaction force R will shift toward the right side. As you can see, this was our center of the shaft, and the reaction force will move to the right side. Why to the right side? Because you are trying to, raise the load. So as you are trying to raise the load, the reaction force will shift towards the right. But if you try to hold the load, like if you are trying to just hold the load over here, then the reaction force, the direction of reaction force will shift to the left side, like over here. We'll see that. So this will be our diagram. Now just simple formulas over here, nothing difficult. So RF, the radius of friction, will be R sine phi. Then as our phi is very small, so we can write it as R into mu s. Actually R sine theta we can write it at R sine, actually sine phi can be written as tan phi, because the angle is very small. Then tan phi equal to, we know that, mu s. So that is how this mu s uh, come from. So RF will be 1 into the radius of the shaft is given, which is 1 inch, and the value of mu s is given in the question, which is 0.20. So you will get 0.20, which is the radius of friction, RF. So now look at the picture over here. So summing the moments about B, we are taking moments about B. So summation of B will be 0, and for this 500-pound load, the distance uh, of W force from B will be this much amount of distance, which is this distance over here plus the small RF. We have calculated the RF over here. So the final answer would be the radius of the pulley, which is 2 inch plus 0.20 inch. Why plus 0.20 inch? Because you have to add this radius of friction, because the distance will be this amount of distance plus the radius of friction. So as you can see over here, minus, okay, so this will give you anti-clockwise rotation, so that's why we have put plus sign over here, and you can see minus sign over here, because this force P will create clockwise rotation. So the moment will be in clockwise direction, so that's why we are putting minus sign over here. Minus y 1.y0, because the distance from this force P to the force R will be this distance. How can we get this? We can get this by, you know, we know this distance because this is the radius, which is 2 inch. So if you subtract this radius of friction over here, this small distance, uh, so you will get the actual distance, which is this one. So if you subtract 2 to 0.20 from 2, you will get 1.80. Then distance multiplied by force, which is the formula for moment, equal to 0. That was our equation. So by solving the equation, you will get the value of P, which is 611 pound. Now vertical force P to hold the load. Now the scenario is kind of similar, but now the reaction force will shift toward the left. That is the difference from part A number of question. Everything remains same. So R shifts in the left side. So now this time the moment for 500-pound force, if you try to find the moment for 500-pound force, we have to multiply it with the distance. So now the distance will be 2 minus 0.20, because you have to subtract 0.20 from 2 inch. Like this is 2 inch, then you have to subtract this much distance, then you will get this distance, your required distance. So that is why you can see 1.80 over here. And now the scenario turns over for force P. The distance will the perpendicular distance will be 2 plus 0.20. That means 2.20 multiplied by P, then you will get the value of P. So for part C of the question, horizontal force P to start raising the load. Now you are applying the force P in the horizontal direction. So the direction of P will be like this over here. So one thing you can notice over here, that these three forces W, P and R will be concurrent. They will pass through the same line. Why they will pass through the same line? Because like if you try to draw a triangle over here, like this is your P, this is a vector, right? This is your P and this is your W, right? The summation of these two vector by the rule of vector addition, it will be somewhere around this in the middle. It will be somewhere around here. So if you want to keep it balanced, want to keep it in equilibrium, you have to apply the same amount of force but in the opposite direction to keep it in the equilibrium state. So the reaction force will be in the opposite direction. So as you can see over here, the reaction force R will be in the opposite direction. So they will definitely in the go through the same point. They will be concurrent, and the point will be this D over here. So as you can see over here, it is written, since the three forces W, P and R not parallel, they must be concurrent. So they are concurrent forces. I hope you have understood the concept behind it. The direction of R is thus determined from the fact that its line of action must pass through the point of intersection D. Okay, yeah, you can read it that out. So sine theta. So what is theta over here? Theta is that angle over here, that small angle. How can you determine it? Determine the angle, like sine theta will be OE opposite by hypotenuse. So OE by OD over here, OD. So OE can be determined, this is the radius of friction, right? OE. So OE can be determined, RF equal to, we know that RF equal to radius of shaft R into mu s. We have determined the value earlier, which is 0.20 inch. So you can see over here 0.20 inch. Now how can we actually get the value of OD? OD, as you can see over here, if you complete the figure, it will look like this. This is actually a square, so OD is the diagonal of the square. So the east side of the square is 2 inch, so the diagonal will be 2 root 2. The diagonal will be 2 root 2. So the value of OD will be 2 root 2. Then you can get the value of sine theta. Now once you know the value of this theta, so if you want to find out this angle over here, this will be simply 45 minus theta, because the total angle is 45. If you subtract this uh, 4.1 degree from 45 degree, you will get the value of this theta, this angle. So now you know the value of this angle over here. Why do you need to know the value of this particular angle? Because if you find the angle over here, you can eventually find the value of P by the triangle law. Look over here, the triangle is drawn over here. So from the first triangle we obtain P equal to W cot 45 by theta minus theta. You can take sine tan theta as well, then you can get the value of P. Simple geometry will be applied over here. So I hope you have understood the problem over here. Now the next problem. The double pulley shown is attached to a 10 millimeter radius shaft that fits loosely in a fixed bearing. Knowing that the coefficient of the static friction between the shaft and the poorly lubricated bearing is 0.40, determine the magnitude of the force P required to start raising the load. So once you have read the statement, now we can go through the problem. So how the FBD, free body diagram, will look like, I have already drawn it for you. The free body diagram will look like this. Over here you can see the FBD, free body diagram of this pulleys will look like this. So as you can see, when you are trying to start raising the load, when you're trying to um, raise the load, so the value of R, the direction of R will shift from the center to the right side. As you can see over here, I can zoom it for you. It will shift towards right side. This is the center of the shaft. The direction of R will shift to the right side. So now you can just simply to get the value of P, you can simply just take the moment about M. M is like, you can denote this point as M. Actually in this figure you can see over here, the point over here is denoted by D, so you will take moment about D. So if you take moment about D, like summation of moment about D will be 0. So to write this in shorter form, the equation will look like this, that the force over here 20 into 9.8, we have to take the weight. So 20 into 9.8 into, now the distance, look, the distance will be the radius of the larger pulley over here, this is the radius, and plus the radius of friction. So you have to add the radius of friction, so it will be 20 into 9.8 into 90 plus, which is radius, plus the radius of friction. The value of radius of friction can be found like Rf equal to, radius of shaft into mu s, so 10 into 0.40, then minus p into Then if you want to find the distance, perpendicular distance, like this distance, you have to subtract the radius of friction RF, this distance, from the actual radius of the smaller pulley. So this time equation will be P multiplied by 45 minus 10 into 0.40. So solving this equation, you will get the value of P, which will be around 449.37 Newton. So the next problem is very much kind of similar, like they are kind of same. So I'm ignoring the problem for now. They are the same kind of problem. So the next problem over here, you can see a lever of negligible weight is loosely fitted onto a 75 millimeter diameter fixed shaft. It is observed that the lever will just start rotating if a 3 kg mass is added at C. If you add 3 kg mass at C, the lever will start rotating. Okay. Determine the coefficient of static friction between the shaft and the lever. Okay. So as you can see over here, the free body diagram of this system, FBD free body diagram, will be like this. So when if you when you are adding 3 kg force, actually 3 kg mass over here, it will like start rotating like this, right? So it will start rotating like this. So as it is rotating, will start rotating in this manner, the RF or the line of action of R will shift in the left side. If there is no motion over here, then the line of action of R will be in the middle, but it is rotating in the anti-clockwise direction, then the line of action of R will shift to the left. So now the question becomes very simple. We can actually determine this distance. This will be the radius of friction, right? So this will be the radius of friction. So our equation will be, so we can just moment balance. So moment about this point, we can denote it like M. Over here the point is M, from which the reaction force R is passing through. So there is a point called M. So moment about M, summation of M moment about M will be 0. So your equation will look like this. Now total mass will be 20 plus 3, that is 23 kg into 9.8, force multiplied by distance. So distance will be, this distance is 150 meter, and you have to subtract this radius of friction from this total distance, then you will get eventually this distance, right? So 150 minus uh, the radius will be this is the diameter, so radius will be 75 divided by 2, 37.5 multiplied by mu, equal to, then here you can see 30 kg, so 30, the force will be 30 into 9.8 into, now again you have to find, here was the line of action of R, so the distance over here is 100, then you have to add the radius of friction this time, so 100 plus 37.5 radius into mu. I don't know the value of mu, that's why I am keeping it as mu. So you have to find out the static friction. So you have an equation which is containing only one unknown, so the value of mu will be 0.226 if you solve it. So this was very simple question. Actually belt friction I can discuss it in the next video.